All right, today what we're going to do is talk about standard form of linear equations. So far what we've talked about before is slope-intercept form of linear equations, where we were going over y equals mx plus b, and we know how to find slope and how to write equations in that slope-intercept form. Well, here is another form that we have to know about, and that's called standard form. So what we're going to talk about, what does standard form look like, and how can we manipulate equations to make them look like standard form. Well, we had that one lesson where we had to manipulate an equation to make it look like it's in slope-intercept form. Well, now we're going to manipulate something to make it look like standard form. So what is standard form? Now, standard form is just some more letters and more letters, just in a different shape, to tell us something about that equation, and we'll get to more of that later. But standard form is an equation that looks like this. I mean, it's quite popular. Standard form is an equation that looks like this. We have ax plus by equals c. So you have an equation with the x term out in front. A is a coefficient. Then you have the y term that's next with b as the coefficient, then the equal sign, and then the constant number that doesn't have an x or y. Now, standard form comes with a couple of rules that you have to know about. And you'll see, a and b have to be integer coefficients. Well, what does that mean? If a and b have to be integer coefficients, what that rule means, since we have rules for standard form, what that means is no fractions or decimals allowed. So where we had, for slope-intercept form, right, when we had y equals mx plus b, if the slope was a fraction, that was okay. In standard form, we can't have fractions. Okay, so that's the first rule. No fractions or decimals allowed. The second rule is that first coefficient, coefficient for x, which we call capital A, the capital A must be positive. And this is a hotly debated rule for standard form. Some people say, well, it doesn't matter if the A is positive or negative. Some people say, well, the A has to be positive. Personally, I am in the school of thought that says A must be positive, but it's hotly debated. Some textbooks have it, some textbooks don't. Some people think it has to be. I'm one of those that think A has to be positive. So in my world, the coefficient for x, that capital A, should be a positive number, and that is standard form. Okay, so these are the things for standard form. Notice the difference between standard form and slope-intercept form. Okay, so slope-intercept form look like this. The y is by itself, then we had the slope, and then the y-intercept. Okay, and the slope was a fraction. So a couple of differences of note. The first thing is, in standard form, this isn't the slope. Okay, A does not represent the slope. You can only tell slope by looking. I'll give you a hint in the next lesson. But you can't say, well, the slope is the number in front of the x. No, that's only in the case of slope-intercept form. The next thing that's different is you think this is the y-intercept. That doesn't mean this is the y-intercept. Okay, so you can't really tell slope and y-intercept from standard form until I show you how. Just notice it's different from slope-intercept form. So you cannot treat the two forms of equations the same. You have to treat each one differently. So let's look at the example that I have set up for you. Just one example is all we need, and you'll see everything else that we need for standard form. So we're going to take this equation and we're going to write it in standard form. Well, the first thing you should notice is that this is not in standard form. There's no way this is in standard form. Okay, standard form looks like ax plus by equals c. The term with the x, the term with that y, the equal sign, then the constant. Look at this equation. This equation has the term with the y, then the equal sign, then a 3/5 x, then a minus 7. Okay, so there's no way you can possibly think that this is in standard form. So you got to play some heads-up ball. So there are a few things that we could do to manipulate this equation to make it look like standard form. The first thing I want to talk about is that one rule that we had where we said no fractions or decimals allowed. So let's deal with that, because if you look here, hey, we got a fraction going on, 3/5 x. So there are no fractions allowed. So let's fix that. Now, how can we clear away fractions? If you remember from previous lessons, the way we can clear fractions is to multiply both sides by the denominator. Okay, so the way we clear fractions is multiply both sides of the equation by the denominator. All right, we're undoing the division piece, and the way we undo division is with multiplication. So if we look at this fraction, it says 3/5, or 3/5, or 3 divided by 5. Okay, what we can do to get rid of that divided by 5 is multiply both sides by 5. So that's what we're going to do to fix that fraction piece. Let's multiply both sides by 5. So we multiply both sides of the equation by 5. Now I'm going to show you something, because this has been a point of confusion. On the right-hand side, I'll show you a thing. So we multiply the left-hand side by 5. We have 5 times 2y. That, of course, is 10y. On the right-hand side, we have to use the distributive property. So sometimes when you're showing work of multiply both sides by 5, the way you could show work is by skipping to the distributive property. 5 times 3/5 x, and 5 times that minus 7. Okay, so that's another way that you can show the work of times 5 on both sides. All right, so here we go. We're dealing with fractions and integers, so we have to be paying attention to this part, right? So on the left-hand side, we still have 10y. On the right-hand side, we have 5 times 3/5 x. Okay, so what does that mean? We're multiplying 5 times a fraction. Well, what is 5 as a fraction? 5/1. And how do we multiply fractions? Straight across. 5 times 3 is 15. 1 times 5 is 5. So we have 15 divided by 5. 15 divided by 5, we all know, is 3. So we have 3 times x. Now, if you were paying attention, why did we multiply everything by 5? Because we're clearing fractions. So look at this little shortcut, if you catch it. If not, well, then keep doing it the hard way until you see the shortcut. By multiplying everything by 5, we've cleared the fraction. All we have left is at 3x. That was the point of multiplying everything by 5. Just remember, we multiply both sides by 5, so 7 times 5 is 35. So we have to be careful, paying attention to what's going on. All right, so now we have this. We've cleared the fraction. No fractions allowed in standard form, clearing the fraction. So the question is this now in standard form? Does this look like this? And of course, if your eyes are open, you can see that, well, this is not the same. In standard form, the term with the x, the term with the y, the equal sign, the c. What we have currently, the term with the y, the equal sign, the term with the x, the c. Well, that can't happen. We have to have this term with the x way over to the left. So it's on the right-hand side of the equal sign. We have to have it on the left-hand side of the equal sign. And the way we do that, move things across the equal sign, is undoing them. So we're going to undo this 3x. And we undo it by taking it away. We can take away 3x here, and we'll take away 3x here, and then move it all the way out to the left so it can match standard form. Okay, notice how I want to put the x way out in the front so it can match standard form. I've subtracted 3x from both sides, so I have negative 3x. This was a positive 10y, so I have plus 10y. And then my equal sign came. Now 3x minus 3x cancels, and it leaves you with negative 35. Don't forget that minus sign belongs to the 35, so it's negative 35. And here I have my equation as it stands, right? The term with the x, the term with the y, the equal sign, negative 35. Standard form looks like this, so it looks like I'm pretty much done. Until I remember that second rule, that hotly debated rule. The rule that I say, A must be positive. So if A is negative, we have work to do. If A was positive, we would be done. But since A is negative, we're not done. So what can I do to make A positive? Technically, you can divide everything by -1, or you could just look at it as changing all the signs. So technically you're dividing both sides by -1. Shortcut, you're welcome, changing all the signs. So this -3x becomes positive 3x, plus 10y becomes minus 10y, then our equal sign is there, and -35 becomes positive 35. Okay, so again, if the a was positive here, we would have been done, but since a was negative, we changed all the signs. Now we have this. Does it matter that this is negative? No, I don't care that this is negative. Would it matter if this was negative? No, it doesn't matter if this is negative. A is what has to be positive. So here we have term with the x, term with the y, equal sign. C, standard form. Term with the x, term with the y, equal sign. C, and we are in standard form. So here is our equation in standard form. So what does that mean? This equation is exactly the same as this equation. You might not believe it, but they are exactly the same. So take a look. Those are the same thing. Okay? And that's how we can change any equation into standard form, by doing some algebraic manipulations. Thank you.